Hi, Amaya. So I'm going to try and answer some of your questions that you emailed to me. So let's get started. This was your first question. When given two plot points, how do you tell which one is going up and coming down? This is a great question because it does depend on the parabola, and what it really comes down to is concavity, whether your parabola is concave up or concave down. So let's look at an example to make it really clear. I took this straight out of your workbook from the homework you had last week from section 4.3. So it said I said think about workbook page 130 to 131. This problem said an astronaut throws a ball to a fellow astronaut on the moon. The height of the ball, h, at time t is given by this equation. H of t equals negative 2.7 t squared plus 35t plus 7, where h is in feet and t is the number of seconds after the ball is thrown. So part F of this question asks, when does the ball reach 100 feet? And so this is sort of the perfect question to visualize that. So I don't know if you remember, but you can feel free to go back into your workbook, pull this up, and once you do, you can pause the video, and then once you do, and you're sort of in the context of this problem, unpause it. So when you solved this problem, you plugged in 100 for H, and you used, and then you set, you did a little bit of algebra to set this equation equal to 0 and use the quadratic formula to solve for t, right? And you found that the ball is at 100 feet after 3.73 seconds and 9.23 seconds. So you get two answers for this, and your question is, how do I know which time represents the ball going up and which time represents the ball going down? All right, so I actually want you to sort of think about this as ordered pairs, okay? So if the time is 3.73 seconds and the ball's at 100 feet, well, that ordered pair would be 3.73, 100. And if the time is 9.23 seconds when the ball is at 100 feet, that ordered pair is 9.23, 100. So let's look at that on a graph, okay? So I actually have those 2 points right there. There they are. Okay, here's the first point, 3.73, 100, and here's the second point, 9.23, 100, okay? So how do I know which of these plot points represents the ball going up and which is going down? Well, if you look at them on the parabola itself, it should be pretty clear, right? This parabola is concave down. It has a negative a value. So we know it's concave down, and you can clearly see that in this picture. So when our x value is smaller, okay, the ordered pair with the smaller x value would then have to be the ball going up. And you can see because the parabola is going up at that point, right? But then after it hits the vertex, you know, the maximum, that ball is going to start to come down after it hits the maximum height. So your plot point, your ordered pair with the larger x value, this one right here, is then going to be the ball coming down. Now, if our parabola had been facing the opposite way, we would have seen, if this had been concave up, we would have seen something a little bit different, right? Then, in that case, the x value with the smaller value, the x value from our ordered pairs with the smaller value would have been coming down, and with the bigger value would have been coming up, okay? It would have been reversed. So it really depends on the concavity of your parabola, okay? So hopefully that helps clear it up a little bit. And then your second point is, your second question was, how do you find the mirror image when given a point and no graph? This is a great question. This one really wants to see if you understand what an axis of symmetry is, okay? So again, I pulled something really similar. Well, I pulled a question out of your workbook, but I changed the numbers because I wanted to be able to put it on this little graph here to make it really clear. So on page 134 in your workbook, there was a problem that was very similar to this. If the point -1, 2 is on a quadratic graph with the axis of symmetry of x equals 1, then find its mirror point, okay? So it gives you the point -1, 2. There it is on my graph. And then it tells you the axis of symmetry is x equals 1. And you really have to understand what the axis of symmetry is. That axis of symmetry represents a line over which we could put a mirror, and when we reflected any point on the left side of the mirror, it would be reflected onto the right side the same way. So we have this point right here, this -1 to this point, and we know that we're going to flip it. We're going to basically take a mirror and put it here, and we're going to see how it's reflected onto the other side of that mirror, right? So how do we do that? Well, we look to see how far away this point, this first point that we have, is from the axis of symmetry. So this point, the x value, it starts at -1. How far is that from x equals 1, or axis of symmetry? It's 1, 2 away from our axis of symmetry. So we had to go over, from our axis of symmetry, we had to go over 2 to the left, okay? Using that logic, well, that means that we're going to have to jump 2 away from the axis of symmetry, which puts us here. And our y-coordinate is going to be exactly the same. So our mirror image will be at 3, 2, okay? Your points have to be equidistant from your axis of symmetry. So if this point was 2 away, then this point has to be 2 away. And you can always check this using subtraction, so we know our mirror point is 3, 2. And you can check this by subtracting the x values. So again, if we look at our axis of symmetry was x equals 1, right? So our x coordinate there is 1. And our first point, the x coordinate was -1. So 1 minus -1, well, that gives me a value of 2, which means that our first point was 2 jumps away from our axis of symmetry, right? Which we see right here. We have 1, 2 jumps, okay? We're just finding the distance. Well, let's make sure that the point that we reflected is now 2 jumps away. So again, we're going to look at those x values. So the x value of that point was a 3. And the x value of our axis of symmetry is, of course, 1. And that does give us 2. So again, we are 1, 2 jumps away from our axis of symmetry. All right, so that checks out. So you really want to think about your axis of symmetry as just a reflection line. Like if you put a mirror there, the points that you see on one side will be directly reflected onto the other side, okay? And you can sort of picture the parabola that goes through this, right? It would sort of be something like, here would be the maximum or the minimum, depending on the concavity of this, okay? So that axis of symmetry is going to cut it right in half, which means whatever is on this side has to reflect onto this side evenly, right? It's like that axis of symmetry cuts a parabola directly in half. Okay, so hopefully that makes that a little bit more clear. And then let's look at your last question. It said, is a parabola always continuous, or does that depend on the situation? So this always comes down to your variables, okay? It really depends on your variables. If the variable can be broken down further, like a measurement, then it would be continuous. So anytime you're dealing with a length or any unit of time, that can always be broken down further. And I think most of the problems, if not all, from the unit we did on parabola did in fact deal with continuous variables. But if the variable cannot be broken down any further, if it's countable, okay, then no, it's not continuous, then it would be discrete. So, and for example, in our previous chapter, I specifically remember doing a workbook problem about rabbits, the growth of rabbits. That's a discrete variable because you can't break down a rabbit, right? You either have 1 rabbit, 2 rabbits, 3 rabbits, or 4 rabbits, but you don't have 4.1 rabbits, okay? That's a countable variable, so that cannot be broken down any further. Another example I put on here is number of concert tickets. You're not going to get into a concert with half a ticket, so we're not ever really concerned about fractions of tickets, right? We can't cut that. You either have 1 concert ticket or 2 concert tickets or 3 concert tickets, but you're not going to have 2.5 concert tickets. So that would be a discrete variable. That would be continuous, or that would not be continuous. So I hope that helps just a little bit. All right. Let me know if you have any other questions. Okay. Thanks, Amaya. Bye.